Okay? So let's factor it. How does it factor? I think it's easy, isn't it? How does it factor?
X minus 1, X plus 4.
Thank you, Harris.
X plus 4 is minus 1.
That's what he said, I think. I don't know what
I just said it the other way around.
Oh, you did say it the other way around?
Yeah, well, I said X minus 1,
that
X plus
doesn't matter.
4, yeah.
That doesn't matter. As long as you got the plus with the 4 and the minus with the 1, the order you do it doesn't matter. So here's my number line. Where are my two dots going to be this time?
1 and negative 4.
At 1 and negative 4. Please make sure you put them on in that order. That's the order they come on the number line. Now, if you want to pick numbers like we did over here to determine the shading, you can always do that. But in this problem, you don't need to because there's no squares or anything on this. So what do we know? If it's a greater than, we're going to be shading outside.
How do you know which one's X and which one's Y? Like, so you know how like for the first one the answer was -2, 3.
Okay, that's not an ordered pair.
Oh, okay.
That's the beginning number and the ending number. That's integral notation. So this one, I'll write less than -4 or greater than 1. So that's one way of writing the answer. If you love your interval notation, you can write it this way. But that's harder, I think. But if you wanted to write it that way, you absolutely could. With a simple little problem with two dots, no squares, you're going to shade inside, you're going to shade outside. Less than is inside, greater than is outside. So you can save the trouble of checking all of these. All right, how about the next one? What do you think about that?
X minus 3, X plus 4.
So first thing you're going to do is factor it. So how does this one factor?
X minus 3, X minus 4.
Excuse this interruption, Mrs. Schwartz.
Yes.
Isabel Kwan has early dismissal.
Okay.
She needs to come to the office. Thank
All
you.
right, take that with you, honey. You gotta check out at the office. See you later. See ya. So now I'm gonna draw my number line. And where are my two dots this time?
3 and
3
4.
and 4. And what about those dots?
They're shaded in.
They're shaded in. And there's only two dots. There's no squaring. So I can use my shortcut. It's a greater than this time. Greater thans are shaded outside. So we have another, just like that one, so we have another two-part answer. X is less than or equal to 3 or greater than or equal to 4 would be one way to write that answer. And another way, if you like this. Now, for this one, be sure that you are using brackets for the 3 and the 4 because it is a closed interval.
Every time it's closed.
Dots.
Oh, wait, never mind.
If it's just a less than or greater than, you use the parentheses. If it's or equal to, you got to use the bracket. The infinities are always parentheses. Okay, so we're going to write it one way or the other. How about B? Oh no, oh no. What did somebody say? I heard it. Synthetic division. Absolutely. You know all that stuff you just learned, took a test over, guess what? It never goes away. You have to factor this. You know there are going to be 3 factors, right? we gotta figure out what they are. What are my PRRs? 6, 3, 2, and 1?
Plus or minus.
Plus or minus over 1? So what do you want to try first? 2? I don't think it works. Let's try -2. Oh, there we go. There we go. Now, what factor do I put here? The root is -2. So what goes in the parentheses? Joe, get your head up, please. What goes in the parentheses? You too, Guadalupe.
1.
X plus 2. That's exactly right. X plus 2. Remember, when you divide, it's the opposite, right? Jalen, if you want to dance, I'll be happy to send you up to Mr. Warland's office and you can perform for him. Now, where do I go from here?
Do we need to boil that out?
Exactly, that's right,
Yeah.
Paris. What's left
Because it'll be X.
is this, and that can factor into what?
3 and 1.
X minus 3 minus 1. So the other two factors are X minus 3, X minus 1. That's old news, right? That's what we know how to do. But now it's an inequality, which means I have to draw a number line and figure out where to shade. So here's my number line. 3 dots, colored in dots. And where will the colored in dots be? -2, +3, +1, in order. Make sure you put them on there in order. Now my inside outside doesn't apply because I have too many dots.
So do we have to do one like?
So we're gonna pick
for
a
each
section.
Plug it
We're
in.
gonna pick a section.
It's pretty
-3.
easy actually. It just kind of takes a while.
Say that louder, Mason.
It's pretty easy. It just takes a while.
Exactly. It's easy. There's nothing hard about this. It just does take a while. So let's pick a number out here.
-3.
-3. So go back to your parentheses and put -3 in. So -3 plus 2.
-1.
-3 minus 3 is not 0. -3 minus 3 is -6. -3 minus 1 is -4. Now multiply all that together. What do you get? These are my 3 parentheses.
-24. You
I get a
shaded.
-24. Is that less than 0?
Yes.
Yes.
Yes. Negative numbers are less than 0. So this gets shaded. If you want to, you can keep doing that for each section. But as long as there aren't any squares or anything funky going on in the problem, the sections will always alternate. Do you remember that from before? So since we colored this one in, I know this one will not be colored, this one will, and this one won't. You can always do the alternating thing as long as your factors don't have any of these on them. When you put that on here, then you have to check every section individually. But as long as you don't have that, you can do one and then color from there. Now we gotta write an answer. So it's gonna be a two-part answer. This part will be everything less than or equal to -2. Or this part will be everything in between 1 and 3. If you prefer, that's embarrassing. If you prefer, you can use integral notation. And again, the brackets are because of the or equal to. Infinities are always open. I use brackets because everything else is or equal to. You can write it this way or you can write it this way, whichever way you feel most confident. Okay? One more like this. Shoot, our quiz might have 2 problems on it. We know we have to factor it, right? And we know there's going to be 3 factors. How do I know there's 3?
Because there's cube.
Cube. So thoughts?
If there was a 4 up there, would it be 4?
I would have did cubes like group them together and then
Yes, Jordan, you're on fire today. Good for you.
just what I figured it's keeping me warm.
Is it? Okay. So Jordan said, all right, Mrs. Ford, I can do what we did over here. I can guess a number and do a division problem. That will work. But I noticed that I could also factor this one by grouping.
Yeah, that's what I was
On the test we took, some of you were not successful factoring by grouping. Some of you looked at the problem and said, I want to group it, but then you messed up the grouping. If you're not comfortable factoring by grouping, you do not have to do that. You can do this instead. If you're not comfortable with either one, you got to figure something out, because those are the 2 ways to do this problem. So I'm going to go ahead and factor by grouping. So out of the first 2 will come an x squared, and then x plus 3 is left. Out of the last 2 will come what?
4.
-4, leaving me with another x plus 3. What has to happen when you factor by grouping? You have to have the common parentheses. If they don't match, you can't do it. And if they do match, you write that parentheses down. Period. Don't square it or do anything else. You write it down. Then the one that's left is x squared minus 4.
Would that be just x minus 2x plus 2?
And that factors, oh, I'll do it up here. That factors into x plus 3, x minus 2x plus 2. So there are my factors, kids. Everybody okay with that? Now, if you did it this way, then you're going to guess some numbers, and the numbers you could guess would be -3, +2, or -2. Those would be the numbers that would work if you guessed.
But x plus 3 would be important.
What?
It's like it'd already be x, like it'd already be like graphed kind of, like
No.
shaded in.
Nothing will be graphed or shaded in.
The thing that we did,
Till now. We have to have all the factors before we start doing that.
Yeah, but wouldn't the 2 overlap the 3? First place?
I'm not sure I understand what you're saying.
alright, well,
I'll try to explain if I
Okay.
can see it.
Yeah.
would the process that we did in the problem before to get the 3 points work also?
Always.
Okay.
That's what I've been saying. Always you can do that. So here's my number line. Here are my factors right here. So the dots are going on the number line. They're open dots. And where are they going? -3, 2, and -2. Joe, what is wrong with everyone today?
Our sleep schedules are messed up.
break.
So fall break.
I think you put something in those brownies.
I'm sure that was it. Okay, now, is anything weird about this problem? No. So I can do my alternating trick, my shortcut if I want, but I still have to check one region to get started. So I'm gonna go ahead and work out here. I'm gonna put in -4, -4, and when I put in -4, I get -1, -6, -2. So I went back to my factors and I put in -4 for every x. And these are the numbers I got. Now I multiply all that and I get -12.
Yep.
Is -12 bigger than 0?
No, it's not.
So I don't shade here, which means I do shade here. No, yes.
You skip one every time, right?
You alternate.
Only if there is no square.
Yeah, if there's no square. If that confuses you, then pick a number in here and check it. Pick a number in here and check it. Pick a number in here and check it. That will always work. Now, what's my answer? My answer is everything between -3 and -2, or bigger than 2. That's what I have shaded. So the interval from -3 to -2, or the interval from 2 to infinity. Now, look at that next problem. It looks different, doesn't it? But you want to hear the really good news? It's done exactly the same way. So where do you think the dots are going to go? At -1 and 3. Any of these things squared or weird? Anything weird about that problem? It's a less than, so where do you think I'll shade?
Middle.
Middle. Again, if you can't remember that, or that confuses you, or doesn't make sense, then simply pick a number, pick a number, pick a number. But if you can remember that in normal problems with 2 dots, less than is inside, greater than is outside, you can save some time. So the answer is everything from -1 to 3, or written this way. Wow, that's easy. Zion, that is easy. Take a look at number 9, Zion. Number 9. How do you think we might start this problem? Number 9 on the sheet, it's not on the board. You need to look at your paper. How do you think you might do problem number 9? What might
Squares, so factor.
factor? Are you getting help? Let's let Zion speak on his own behalf. Okay. How does the numerator factor, Zion?
It's a 3.
So x minus 3, x plus 3. And how does the denominator factor? X minus 2, x plus 2. Perfect. And that one is greater than or equal to 0. Now, this is a big problem. How many dots does it have? 4. And where are the dots going to be? 3 and negative 3. 2 and negative 2. This is a lot to keep track of. Make sure you put them on there in the right order, okay? Now, here comes a tricky thing. You look at this sign and you immediately think, oh, I'm going to color in all those dots, because that's what we do. When it's or equal to, we color in the dots. You can never, ever color in denominator dots. Denominator dots cannot be colored in. Because, Max, what happens if I let x equal 2?
If you let x, 0 cannot be the denominator.
Exactly. So there's no way x can equal 2 or negative 2, right? So I'm going to go ahead and color in the other dots. But even though there's an equal to in the problem, these can't be colored. Denominator dots are open. Joe, denominator dots are open. Now, I'm going to start shading. So I'm going to pick one number. Let's do negative 4. Negative 4 would give me negative 7 times negative 1 over negative 6 times negative 2. Negative 4 here, 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 and here. That works out to be positive 7 over 12, doesn't it? Is positive 7 over 12 bigger than 0? Yes. So this is going to be shaded.
And then we just go every other one.
And then we go every other one. Why are we allowed to go every other one?
Because there is no square.
No squares on any of these. The factors are just regular factors. So shade, no shade, shade, no shade, shade.
That's how you get the negative 7.
You can alternate.
That's how you get that.
Now, again, if that confuses you, you're bothered by that, remember how I chose a number here like negative 4? You can choose a number here, 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 and here, and do that all the way down the line. But if there are no squared factors, you don't need to worry about that. You can alternate. So what's my answer? Everything less than or equal to negative 3, or between negative 2 and 2, or bigger than or equal to 3. If you want that in an interval, you can do it. That would be the interval if you wrote it as an interval. So tomorrow we'll take or can I see you again? We'll do a practice problem, and then we'll take a quiz.
So all the every single exercise. Yeah.